Welcome to the Deep Dive.
Great to be here.
Today we're jumping into a really fascinating story from, well, the history books of astronomy.
That's right. We're talking about Vulcan.
Not the Star Trek planet, though.
No, definitely not. This was a hypothetical planet that scientists, serious scientists, once really believed orbited between Mercury and the Sun.
But spoiler alert, it turned out to be a phantom. We're using Wikipedia's article on Vulcan, hypothetical planet, as our guide here.
And our sort of mission today is to figure out, why did people believe in it so strongly?
Yeah, what was the evidence they thought they had? And, crucially, how did this idea eventually get replaced by something, well, revolutionary?
It's a great story about how science works, really. Mistakes and corrections.
Okay, so let's dive in.
Right.
Where does this idea even start?
Well, it's interesting because the idea of something closer to the Sun than Mercury wasn't totally new in the 19th century. People had seen
Things. Like what kind of things?
reports going back to the 17th century. Christoph Scheiner, for instance, saw dark spots crossing the Sun back in the 1600s.
Oh, right. But those turned out to be sunspots, didn't they?
Exactly. Kind of ironic. But later on, you had others, Capel Loft, Gruthus, and Pastorff also reporting shadowy objects moving across the Sun.
But these were just anomalies. They weren't trying to explain Mercury yet.
Not really, no. They were more like curiosities, isolated observations. The connection to Mercury's orbit, that came later.
When did it become more concrete? More than just maybe there's something there.
That started picking up steam around the mid-1800s. You had Thomas Dick in 1838, then Jacques Babinet in 1846, actually proposing an intramercurial planet.
And Babinet even named it Vulcan.
He did. A pretty fitting name, for a planet so close to the Sun's fire. So it shifts from just weird sightings to, like, a potential scientific solution.
A solution to what, though? What was the problem they needed solving?
That brings us to the orbit of Mercury and the challenge of actually seeing this hypothetical Vulcan.
Right, because it would be lost in the sun's glare almost all the time. Super hard to spot.
Extremely difficult. That's why astronomers started systematic searches, hoping to catch it during a transit.
When it passes directly in front of the sun from our perspective.
Exactly, like a tiny silhouette. People like Heinrich Schwab, Edward Claudius Herrick, they were looking intently. And then comes Edmond Modeste Lescarbault.
Okay, Lescarbault. He sounds important.
He is. He was a French doctor, an amateur astronomer, and he starts searching seriously in the 1850s. And in 1859, he writes a letter, a very important letter.
Who did he write to?
To Urbain Le Verrier.
Le Verrier. Okay, the Le Verrier, the guy who found Neptune.
The very same. He was basically an astronomy superstar at the time. He predicted Neptune's existence using math based on wobbles in Uranus's orbit. It was a massive confirmation of Newtonian physics.
So his reputation was huge. If he got involved, people would definitely listen.
Absolutely. And he had been working on Mercury since 1840, actually. Francois Arago had suggested he look into it.
And what was the issue with Mercury?
Its orbit wasn't behaving quite as Newton's laws predicted. Specifically, its perihelion precession.
Okay, break that down. Perihelion is the closest point in its orbit to the sun.
Correct. And that point slowly shifts around the sun over time. That's the precession.
And Newton's laws predict how fast it should shift.
Yes, but Mercury's observed precession was slightly faster than predicted, by about 43 arcseconds per century.
That sounds incredibly tiny, 43 arcseconds.
It is tiny, but it was measurable, and it was persistent. It just didn't fit the Newtonian model perfectly, a real puzzle.
So Le Verrier thought another planet, like with Neptune.
Precisely. He drew on his Neptune success and hypothesized that this extra precession was caused by the gravity of something inside Mercury's orbit, maybe one planet, maybe a ring of asteroids. He called the potential planet Vulcan.
And his track record made this seem plausible, very plausible.
Extremely plausible. And then, bam, December 1859, Lescarbault's letter arrives.
Saying what? I found your planet.
Pretty much. He claimed he'd seen Vulcan transit the sun back on March 26th of that year.
Wow. So Le Verrier must have been thrilled.
Well, yes. But he was also a careful scientist. He didn't just take the letter at face value. He actually traveled, unannounced, to Lescarbault's home observatory.
Showed up on his doorstep.
Yep, to basically interrogate him, check his methods, see the setup.
What was Lescarbault's story? What did he say he saw?
He described seeing this small, round, black dot moving across the sun. Said it looked like a Mercury transit he'd seen before, but smaller.
And his equipment? Was it sophisticated?
Apparently not very. Le Verrier noted it was pretty crude. Lescarbault had timed the transit using an old clock, and get this, his own pulse to count seconds between pendulum swings.
His pulse? Seriously?
That's the story. Despite the basic setup, Leverrier was apparently convinced by Lescarbot's sincerity and description.
So convinced that.
So convinced that in January 1860, just weeks later, he announced the discovery of Vulcan to the Paris Academy of Sciences.
Based on just that one observation.
Based primarily on that one observation by Lescarbot. And Lescarbot became famous overnight. He even got the Légion d'honneur.
Incredible. So, case closed. Planet found.
Not quite. Almost immediately, doubts started creeping in.
Oh. From who?
Well, a key figure was Emmanuel Liais, another French astronomer, but he's working in Brazil with a much better telescope. Now, Liais stated very clearly that he'd been observing the sun at the exact same time Lescarbot claimed his sighting, and he saw absolutely nothing out of the ordinary.
Ooh, that's problematic. Better telescope, same time, nothing seen.
Exactly. It cast a pretty big shadow over Lescarbot's claim. And remember, Leverrier had calculated this whole orbit for Vulcan based just on Lescarbot's numbers.
Right, you mentioned that. He gave its distance, period, tilt. Seemed very precise for one potentially shaky sighting.
Suspiciously precise, perhaps. And then things got even murkier.
How so?
Well, after the announcement, suddenly other people started reporting transits. Amateur astronomers, mostly.
Like a Me Too effect.
Kind of. Reports came in from London, Manchester, Washington territory. People claiming they'd seen it, sometimes years earlier. F.A.R. Russell, Richard Covington, Mr. Loomis.
Were these sightings consistent? Did they match Leverrier's orbit?
Not really. That was the problem. They were often vague or the timings didn't quite fit. For instance, after Loomis reported a transit in 1862, two different astronomers calculated Vulcan's orbital period based on it and got different answers.
So the evidence wasn't exactly stacking up neatly, more like a confusing jumble.
A confusing jumble is a good way to put it. Lots of noise, not much clear signal.
Okay, so observations are iffy. Did anything else happen to boost the Vulcan idea?
Yes. The next big wave of excitement came during a total solar eclipse, July 29th, 1878.
Ah, because the sun's glare is blocked. Perfect time to look for something nearby.
The perfect time.
Yeah.
And two very reputable, experienced astronomers claimed they saw something.
Who were they?
Professor James Craig Watson, who discovered tons of asteroids, and Lewis Swift, famous for finding comets. Serious observers.
And they both saw Vulcan.
They both reported seeing a reddish, star-like object near the sun where no known bright star should be. Watson even thought it looked like a small disk, not a point source, and maybe even showed a phase.
A disk? That sounds promising. Like a planet, not a star.
It certainly sounded like the best evidence yet. Two experts, independent sightings during an eclipse.
But there's always a but in this story, isn't there?
There usually is. The big problem was the reported positions for this object didn't agree with each other.
They saw it in different places.
Significantly different places. And neither position matched Leverrier's predicted orbit for Vulcan, nor any known star once charts were checked carefully.
So what was going on? Misidentification.
That was the suggestion from skeptics like C.H.F. Peters. He argued they might have mistaken known stars near the sun, perhaps getting the positions wrong in the excitement and difficulty of eclipse observations. The recording methods weren't perfect.
So even the best potential evidence was controversial.
Highly controversial. And as more eclipses came and went, 1882, 1883, all the way up to 1908, nobody else confirmed the sightings?
People were still looking, though.
Oh, yes. Especially the Lick Observatory. They conducted really thorough photographic searches during several eclipses, trying to capture Vulcan on camera.
And the result?
Nothing. Their detailed photographic plates showed no sign of an intramercurial planet of any significant size. They basically concluded the observational search was a dead end.
So the sightings dried up, the photographic evidence wasn't there, Vulcan was looking pretty shaky.
Very shaky. The observational case just kind of fizzled out due to inconsistencies and lack of confirmation.
And then came the final blow.
Then came the revolution. 1915. Albert Einstein.
General relativity.
General relativity. A completely new way of thinking about gravity. Not as a force, but as the geometry of space-time itself being curved by mass and energy.
And this somehow explained Mercury's weird orbit.
It explained it perfectly. Einstein's equations predicted that the sun's immense gravity would warp space-time around it, and this warping would cause an extra precession in Mercury's orbit.
How much extra?
Exactly 43 arcseconds per century.
Whoa! The exact amount that was unexplained by Newton.
The exact amount. without needing any mysterious planet Vulcan. It just naturally emerged from the mathematics of general relativity.
That's elegant.
Incredibly elegant. The problem that had puzzled astronomers for decades, the very reason Vulcan was proposed, just dissolved in this new understanding of gravity.
Did relativity affect other planets' orbits too?
Yes, but the effect is much, much smaller for planets further from the Sun's gravitational well. Mercury, being the closest and having a fairly elliptical orbit, showed the effect most dramatically.
So relativity provided the answer. Was there like a big moment when everyone just accepted it and forgot Vulcan?
Well, the acceptance grew, especially after
Oh,
1919.
what happened in 1919?
Another solar eclipse. Arthur Eddington led expeditions to observe starlight bending as it passed near the Sun, exactly as Einstein's theory predicted.
Ah, the famous Eddington experiment. That confirmed relativity's view of gravity.
It was seen as powerful empirical proof. If relativity was right about bending starlight, it was almost certainly right about Mercury's orbit, too. The need for Vulcan just evaporated.
So Vulcan the planet was finally laid to rest by better physics.
Pretty much, science moved on, armed with a deeper, more accurate theory.
Does the name Vulcan live on in astronomy at all?
Sort of. The International Astronomical Union has reserved the name Vulcanoid for any hypothetical asteroids that might still exist within Mercury's orbit.
Ah, so maybe not a planet, but maybe smaller rocks?
Maybe. There's a theoretically stable zone there. And people have looked. Earth-based telescopes, space probes like the Parker Solar Probe getting super close to the Sun.
And found any volcanoids?
Nope, not a single one confirmed so far. That inner region seems surprisingly empty of anything substantial.
What an amazing journey for an idea, though. From these early fuzzy sightings
To a real scientific puzzle needing an answer.
to a discovery championed by a top scientist.
Then decades of doubt and failed searches.
And finally, being completely superseded by a revolutionary theory. It really shows how science progresses, doesn't it? Trial and error, challenging assumptions.
Absolutely. The aha moment wasn't finding Vulcan, it was realizing we needed a whole new understanding of gravity itself.
It really makes you wonder, doesn't it, thinking about the science we accept today?
How many things we take as scientific fact right now might, eventually be overturned or radically changed by some future discovery?
What current mysteries out there could lead to a similar kind of revolution in thinking? It's a fascinating thought.
Definitely something to ponder. There's always more to learn.
Well, if this story has piqued your interest, you could definitely explore the history of general relativity more, or look into how eclipse observations evolved, or even the ongoing hunt for those elusive volcanoids.
Lots to explore.
Indeed. Thanks for joining us on this deep dive into the phantom planet Vulcan.